Hi, my name is Manish Gupta, and in this video, I'm going to talk about this interesting idea called as Prompt2Model, that is generating deployable models from natural language instructions. So, as the name says, the idea is literally, can you write a prompt so as to directly give you a model to solve a particular task in mind? Okay. So what is Prompt2Model? Well, this diagram on the left explains the broad idea. So let's say if you have an input that I want to do this task. I want to answer questions given context from a relevant Wikipedia article. That's your task description. Now, you can just give the task description or optionally you can give some examples also. And what the entire system, this Prompt2Model system, what the entire system should do is to basically give you a efficient deployment ready model. Right? For example, in this case, the system could actually produce a model with a Bertsch score of 94, CHRF++ score of 58.9, and an exact match score of 61.5. Right. So, this particular model, which is generated by this Prompt2Model system, essentially can then take questions with context, like what does LPC stand for, and the context, whatever is the passage, and then give you then an answer, linear predictive coding. Okay. So what does Prompt2Model do? Well, it basically has to take the task description and output the model. But internally, it does three main things. It retrieves data, it generates data. So these are basically to create data sets. And then it also selects an existing pre-trained model and retrieves it and basically fine tunes it on the retrieved and generated data. That is what it does. Okay. So in more detail, what is shown, more details are actually shown on the right side. So for example, if you have the task answer questions given context from a relevant Wikipedia article, and you give some examples also optionally. So it basically the prompt plus few examples are taken by an input parser. Input parser tries to extract the prompt specification from the input. So it basically gets instruction and QA pairs. And then the Prompt2Model system, which is practically this part, has from model retriever, it figures out which of the existing pre-trained models from Hugging Face is a good fit to solve the problem. It also has a dataset retriever to retrieve relevant datasets and a dataset generator to generate new data, right? Which can, which is basically then both used. Retrieve dataset and generate a dataset is used to train the model. So this retrieved model is basically, used to train, is the one which is used to fine tune on the retrieved data and generated data so as to get a trained model. Now, of course, on the generated test data, they basically use the trained model for evaluation, and then they estimate the performance using GPT, Chat GPT kind of model, and that basically gives them such awesome results as we mentioned there as well. They of course also build an interactive demo on top of all this. So for example, here the retrieved model checkpoint was Flan T5 base, and essentially the retrieved data set was children's book test. Well, they also generated some training set automatically using the Prompt2Model system. Okay. So overall, the automated pipeline, it extracts essential task information from the user's prompts and then auto collects and synthesizes task specific knowledge. Okay. Has three parts to it: dataset retrieval, dataset generation, and model retrieval. Right. So dataset retrieval, and then dataset generation, and then model retrieval. So that's that. Now, how does Prompt2Model work? Well, there is a prompt parser, as we basically mentioned, this prompt parser, input parser, which is basically parsing the prompt. And the prompt parser is basically GPT 3.5 Turbo 0613. Right? Then there is a dataset retriever, dataset generator, and model retriever as expected. Dataset retriever essentially retrieves the most relevant data from the large set of Hugging Face data sets. Basically, to retrieve the most relevant data set for the task, it basically uses data finder, which is basically a trained by encoder retriever to rank the most relevant data sets. So after the data finder has basically figured out similarity between the task and the task description, on Hugging Face, and computed top 25 from data finder. Then they have a manual step where the user manually selects the most relevant data set from the top 25. So there is a small manual step here. Okay. And then the user also manually identifies, given the dataset, which of those dataset columns are useful for input and output. Okay. So just the dataset finding the top 25 is done automatically using data finder from Hugging Face datasets, but then which columns to use for input and output and which of the top 25 to use is decided by a human in the loop. Okay. Now, some part of the data is also generated. So they produce synthetic data instances using high diversity and few shot prompting. So they try to ensure that in the prompt, they ensure that high diversity data set is generated using few shot prompting. So of course, there are challenges when you're trying to generate data set. Cost efficiency, you want to have as small cost as possible. You want to generate lots of data very quickly. There needs to be example diversity, and then there also needs to be good quality data, which can be useful for the task that the user is interested in. Okay. And then the last component is model retriever. So this component essentially, retrieves any pre-trained encoder decoder model which is hosted on Hugging Face, and which is so it is hosted on Hugging Face. Now, the way this works is as follows. They take all the models, pre-trained encoder decoder models from Hugging Face. They take the user generated descriptions and metadata and index those in a particular and store them in a particular index. Now, when a user generated task comes or a user input task comes in, like your task is to generate an answer to a natural question, and this task, the input is a string that consists of both a question and a context passage. They pass it through the same LLM, the same GPT 3.5, and ask it to come up with this hypothetical document embedding, right? So essentially, so the first step, you take the user task, the prompt parser parses the task description. So this is the task description, and you pass this through the LLM so as to get the hypothetical document embedding. Now, this hypothetical document embedding is actually, so you use GPT 3.5 Turbo, create a hypothetical document embedding, and then you've already indexed all the Hugging Face data sets in your repo, in the index. Now you basically do a BM25 between the hypothetical document embedding that you've created, that is the query, and the existing models in your index. And you rank by BM25, multiply by log of number of downloads plus 1, and return the most matching data, most matching model. Okay, so remember here, they have also used number of downloads plus 1 because typically people believe that most downloaded models on Hugging Face are really good models, and therefore you would want to sort of download that model and use it. Okay. So now how does so in this particular case, for example, Flan T5 base was retrieved exactly because of this reason that well, it basically matches this hypothetical document embedding a lot. And second, it has lots of downloads. Yeah. OK, so how does Prompt2Model perform? So to evaluate performance, they basically did that on two different data sets, or rather three different data sets. Well, they used squared, mCoNala, and temporal question answering data set. Okay. So they trained using, of course, the generated and retrieved data set using AdamW for 3 epochs, which just takes 1 hour for all tasks. Now, if you really look at it, if you wanted to train a model which can do question answering, let's say 2 years back, it would have taken forever to do that because you first need some labeled data to train it and so on and so forth. But here, we have an automated dataset retrieval, automated dataset generation, automatic deciding which pre-trained model is the best. And then, you just need 1 hour to actually fine tune it on the generated and the retrieved data. Okay. So the method, the Prompt2Model is basically evaluated on these 3 metrics, exact match CHRF plus, and also Bertsch score. Okay. So what you observe, well, they basically evaluated, in fact, for other kinds of tasks also, like machine reading, question answering, Japanese natural language to code, temporal expression normalization, and so on. So what they observed is that on 2 out of 3 different tasks, Prompt2Model is 20 point better than GPT 3.5 Turbo. So this is standard GPT 3.5 Turbo. Now you would ask, hey, take this question answering task. Can I basically just ask GPT 3.5 Turbo, give the question, give the passage, and come up with the answer? Okay. So GPT 3.5 Turbo scores 42.1 in terms of exact match, while their model basically scores 61.5. Prompt2Model based Flan T5 based model. Okay. Of course, fine-tuned on these specific generated and retrieved data sets. Okay. Similarly, if you observe the temporal expression normalization task here, you observe that GPT 3.5 Turbo just gives 30.7, while their model gives 55.2. So about 20 points better performance using their model, right? But on the other hand, yes, I mean, for this particular task of Japanese natural language to code, their model is not as good as the GPT 3.5 Turbo model. However, notice that on 2 of these 3 tasks, this one and this one, their model is actually better than GPT 3.5 Turbo, despite being 700x smaller. And of course, their model is basically pre-trained Flan T5 based model, fine-tuned on the generated and retrieved dataset. Okay. Now, they also evaluated how important this retrieval and the generation, both the steps are retrieved data and generated data, and they observed that combining retrieved and generated data sets is powerful. It is actually better, to ensure that you have both the retrieved and the generated data set so as to get the best accuracy. They actually take 3K samples from the closest retrieved data set, which is the children's book test data set in this case, and 3K samples which are generated by the model. And the interesting part is that these 3K samples, which are directly taken from the existing dataset, have an annotation cost of 0 because the dataset already exists. Now, the generation only basically involves a cost of about $5 because the generation, the labeling is actually done using the GPT model, right? Basically, the API has some cost. Okay? So overall retrieval plus generation just costs $5. However, on the other hand, if you basically took those 300 samples and got human labeling done, it would have costed like $540 plus extra time to get that done and quality issues and so on and so forth. Okay. So Prompt2Model basically allows for similar performance at less than 1% of the cost. Okay. So in summary, in this video, I talked about Prompt2Model, which is a framework for generating a small but still very accurate model from a prompt, right? It's literally Prompt2Model. You give a prompt where you specify the task and you get a model which basically performs really well. So it can directly use to produce task-specific models that outperform large language models in a few hours without any manual data annotation or any architecture design. It's basically, the plus version of no-code machine learning or no-code deep learning. Okay, if you want to try it out, you could basically go to that link and try it out. Okay, so that's it. Hope you liked the video. Thank you for watching. Connect with me on my LinkedIn or look at my research on my homepage. Thank you.